Hello students and welcome to part 2 of lesson 4. In this lesson we are going to start to apply these 3 steps that we learned on how to solve a one-step equation. Remember, we want to look at the algebraic side, decide what operation is acting upon the variable, and do the inverse operation to each side of the equation to isolate the variable. As a side note, it is very important for you to show all your steps, even for these one-step equations, where you may be able to visualize the answer from the get-go, because the organization of solving equations begins with this lesson. And when you get up to multi-step equations that take 4 or 5 steps to solve, or when you get up to the next unit, whenever you have 2 variables, you're going to need those organization skills. So any work that you do, whether it be in this guided notes packet, in your classwork, or on your mastery check, must have all inverse operations shown on both sides of the equation, just as I show you in this video. Okay, so let's first start with 2 examples. Let's start with the one on the left. Our first step is to look at the algebraic side. So we know this is our algebraic side, and some students like to put like a dotted or a solid line down the center of their equals to show the 2 sides of the equation. We have the left side and the right side. If we look just at the algebraic expression here on the left, we can start to identify what operation is acting upon this variable, which is the x. There is only one operation acting on the variable on this side of the equation, and that is to add 8. Well, what do you think the opposite of adding 8 is? Well, the opposite of adding 8 is to subtract 8. Those are inverse operations. So instead of putting plus 8, we're going to put minus 8. And the reason we want to use that inverse operation is because positive 8 minus 8 makes 0, and x plus 0 is just x. So in other words, this term eliminates because it equals 0. But remember, what we do to one side, we have to do to the other, so we're going to take 8 away from this side. Negative 2 and negative 8 make negative 10. So x equals negative 10. And you can substitute that back in to see if it indeed makes it true. Does negative 10 plus 8 equal negative 2? And the answer is yes. So this is our solution. The only value of x that will make this equation true is negative 10. Now let's look at this second example. And I purposely picked this one because it has the terms reversed. Do you see how in this one we had the variable plus 8? In this one we have the constant plus the variable, 10 plus x. Remember back to last unit when we talked about how important it is to look at the sign in front of a term. If you look at the sign in front of the 10, you can see that this says positive 10. Anytime you have a constant leading your equation, put a sign there to remind yourself whether it's positive or negative. Now let's go through our steps. First, we need to look at the algebraic side of our equation. So we have positive 10 plus x. Second, we need to decide what operation is acting on this variable. And the operation is positive 10 because of the positive sign in front of the 10. Positive 10. Well, what is the opposite of positive 10 or adding 10? And that is to subtract 10. This makes sense to do because positive 10 minus 10 makes 0 or eliminates, because 0 plus x is just x. But what we do to one side, which was subtract 10, we must do to the other side. So we must subtract 10 on this side. 30 minus 10 makes 20. Which makes sense because doesn't 10 plus 20 equal 30? So these are 2 examples where the operation acting on the variable was addition, and we had to use subtraction to isolate the variable. Now let's look at some examples where subtraction is acting on the variable. Just like in the last problem, we're going to look at the algebraic side. We can see that x is subtracting 13. Well, what is the opposite of subtracting 13? Well, the opposite of subtracting 13 is to add 13. So to add 13 to each side, which makes sense because negative 13 plus 13 makes 0, and that eliminates because x plus 0 is just x. Negative 5 plus 13 makes positive 8. You can substitute back in to make sure it makes sense. Does 8 minus 13 equal negative 5? And yes, it does. Now again, we still see subtraction in this problem because the terms were reversed, and we always look at the sign in front. So if we look at the side with the x, the operation acting on the x is negative 3. Well, how do you eliminate negative 3? In other words, what's its inverse operation? Positive 3 or plus 3. So we'll add 3 to each side. Negative 3 plus 3 makes 0. 0 plus x is just x. 5 plus 3 is 8. Now let's look at two examples where multiplication is the operation acting on the variable. We are still taking the same steps. We're looking at the algebraic side, and we see our variable, which is x, and the operation acting upon it is times 2, and I know that because they're touching. So what is the opposite of timesing by 2? Well, the opposite of timesing by 2 is to divide by 2. So I'm going to draw a divide bar, not a divide symbol, because we could at some point have shared division. So divide by 2 on each side. 2 divided by 2 makes sense to do because 2 divided by 2 is 1, and 1 times x is just x. So in other words, the 2 and the 2 eliminate because they equal 1, and 1 times anything is just itself. We divided 2 on the left, so now we need to divide 2 on the right. 18 divided by 2 is 9, which makes sense because you know 2 times 9 is 18. Alright, let's look at another example. Do not be confused by the sign in front on this one, because this is actually multiplication of negative 2. So what do you think the opposite of multiplying by negative 2 is here on the algebraic side? Well, the opposite of multiplying by negative 2 is to divide by negative 2. So we're going to divide each side by negative 2. This makes sense because negative divided negative is a positive, and 2 divided by 2 is 1. So we get 1, positive 1, times x, which is just x. Negative 18 divided by negative 2 makes negative 9 because a positive divided negative is a negative, and 18 divided in half is 9. So x equals negative 9. Let's look at two examples where division is the operation acting upon the variable. So let's look at our algebraic side, and if we read it, it says x divided by 4. Well, what's the opposite of dividing by 4? Well, the opposite of dividing by 4 is to multiply by 4. So we're going to multiply this whole side by 4 and this side by 4, which makes sense to do because 4 divided by 4 makes 1 or eliminates. So we get 1x equals, and negative 2 times 4 makes negative 8. So x equals negative 8. Here on the right, we have a very similar example. The only difference is that x is now not being divided by 4, but by negative 4. So the opposite of dividing by negative 4 is to multiply by negative 4. So we're going to multiply each side by negative 4. Negative 4 divided by negative 4 makes 1, or 1x, or just x. Negative 2 times negative 4 makes positive 8, because a negative times a negative is a positive, and 2 times 4 is 8. Okay, we're going to look at one more set of examples. Now, remember, in this example, we are going to see multiplying a fraction. And the inverse operation of multiplying a fraction is to multiply the reciprocal, the same digits upside down. And I'll show you why we do that in a minute. So let's look at our algebraic side. X is being multiplied by 2/3. So what's the opposite of multiplying by 2/3? Multiplying by the reciprocal, so reverse the numbers, 3/2. So we're going to multiply each side by 3/2. Now some of you might say, well 20 doesn't have a denominator, but it really does. It has a denominator of 1, so if you want to write over 1, you can to help you understand that it does have a denominator of 1. Now this makes sense to do because 3 times 2 is 6, and 2 times 3 is 6, and 6 divided by 6 makes 1. In other words, this will eliminate because it equals 1, and 1 times x is just x. Now, on this side, we need to multiply by 3/2. Multiply straight across. 20 times 3 is 60. 1 times 2 is 2, so we get 60/2. 60 divided by 2 is 30. If you didn't know that, you could do that on the side of your paper. Now, this example is very similar to the last one. The only difference is that we're multiplying by a negative fraction. So what do you think the opposite of multiplying by negative 2/3 is? Multiplying by negative 3/2. So we're going to multiply by negative 3/2, which makes sense because a negative times a negative makes a positive. And we already talked about how 3 times 2 is 6, and 2 times 3 is 6, and 6 divided by 6 is 1. So we get positive 1 times x, which is just x. Now what we do to one side, multiply negative 3/2, we need to do to the other, multiply negative 3/2. This time we have a positive times a negative, so that makes a negative. Now multiply straight across. 20 times 3 is 60 over 1 times 2, which is 2. So x equals negative 30. Now let's summarize what we've learned. An equation, let's just say an equation there. An equation is a statement that two amounts are equal. So as we just said, an equation is a statement that two amounts are equal. To solve an equation, we have learned to use inverse operations to isolate the variable. Inverse operations are operations that undo each other, and we learned 4 major sets: add and subtract, multiply and divide, multiply a fraction and multiply its reciprocal, square a number, and square root a number. When inverse operations are used, the variable will be isolated to give you the solution, which is a value of the variable that will make the equation true.